This is SpaceTime Series 25, Episode 97. Coming up on SpaceTime, the Solar Orbiter spacecraft hit by a massive coronal mass ejection, a new study shows Mars' dryness runs deep, and new space travel health warnings. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Earlier this month, as the European Space Agency's Solar Orbiter undertook its third flyby of the planet Venus, it was slammed by a huge coronal mass ejection blasting out from the Sun. The powerful geomagnetic storm hit the spacecraft just 2 days prior to its closest approach to Venus. Scientists say the solar storm demonstrates why it's important to monitor space weather events. Now, fortunately, there were no negative impacts on the spacecraft. That's because it's designed to withstand and in fact measure violent outbursts from the Sun. Although Venus doesn't get off so lightly. You see, coronal mass ejections have a tendency of eroding Venus's atmosphere, stripping off gases as they stream by. Solar Orbiter is now a quarter of a way through its decade-long mission to observe the Sun close up and get a look at its mysterious poles. The spacecraft's orbit was chosen to be in close resonance with Venus, meaning it returns to the planet's vicinity every few orbits in order to use Venus's gravity to alter its own orbital trajectory. And this third flyby saw Solar Orbiter pass within 6,000 kilometers of the planet's surface. Its distance from Venus, angle of approach and velocity were all meticulously planned to get the exact desired effect from the planet's gravitational pull, slingshotting the probe into a new flight path that'll see it pass 4.5 million kilometers closer to the Sun than before. Mission managers are still evaluating the plethora of data coming from the probe following the event. The observations are showing how the local space environment changed as the giant coronal mass ejection swept by. While some instruments needed to be turned off during the close approach to Venus in order to protect them from stray sunlight reflected off the planet's surface, Solar Orbiter's in situ instruments remained on, recording among other things an increase in solar energetic particles. Solar energetic particles are mostly protons, electrons and ionized atoms like helium, which are constantly streaming out of the Sun in the solar wind. But when large solar flares and coronal mass ejections erupt, these particles are picked up and carried with them, accelerating them to near relativistic speeds. And at these sort of energies, these particles can damage delicate electronics on spacecraft or pose a real radiation threat to astronauts in orbit. They can also punch through the Earth's protective magnetic shield, affecting navigation and communication systems and even triggering power blackouts. This report from ESA TV.
Built by Airbus in the UK, engineers had the challenging task of designing a mission capable of observing the Sun as close as 42 million kilometres away, within the orbit of Mercury.
The spacecraft has a number of key new technologies that have been developed just for the purpose of flying close to the Sun. We have a specific heat shield designed just for Solar Orbiter that will reach temperatures of over 500 degrees centigrade on the front side and will keep things as cool as just about 50 degrees centigrade on the backside to protect the sensitive electronics.
The Sun generates a bubble of plasma enveloping the entire solar system. Known as the heliosphere, anything within it, including Earth, is subject to a stream of charged particles called the solar wind. Violent space weather from flares and coronal mass ejections has the potential to damage satellites, disrupt communications and knock out power grids on the ground. Solar Orbiter will help answer fundamental questions about the Sun's activity.
One of the key questions the scientists have is how the heliosphere is actually generated and how it's accelerated. So what is really driving the solar winds? And the second key question of the mission is understanding what makes the Sun change or vary over this 11-year cycle that we all know. So understanding the magnetic properties of the Sun and how these change over this 11-year cycle is one of the key scientific objectives of Solar Orbiter.
To measure the magnetic environment around the Sun, Solar Orbiter is fitted with extremely sensitive instruments. And to capture the closest ever pictures of our star, the heat shield has peepholes through it, covered by protective doors.
We're going to places where no other solar telescopes have been before. We're going to be very close to the Sun to take very high resolution images of the Sun, unprecedented spatial resolution, and we are also going to fly over the poles of the Sun, regions that are very much unknown because we don't see them very well from Earth, but they are the source of the fast solar wind and therefore are very important.
To reach this orbit, Solar Orbiter will use the gravity of Venus and Earth over the course of several years. Solar Orbiter is building on the rich legacy of ESA's previous missions to the Sun, including Ulysses and SOHO. In orbit around our star for more than 20 years, SOHO is still returning spectacular images. This new solar mission will complement NASA's Parker Solar Probe, which launched last year.
We will not get as close to the Sun, but we will have a vastly bigger payload complement, so more instruments with more cameras looking at the Sun. So we will do science that is complementary to Solar Probe, and the two will really have a great deal of synergy.
Scientists and engineers have been working on ESA's Solar Orbiter mission for more than 20 years. They can now look forward to unravelling the mysteries of the Sun.
And in that report from ESA TV, we heard from ESA Solar Orbiter project scientist Daniel Mueller, ESA's Solar Orbiter project manager Cesar Garcia, and Solar Orbiter's principal investigator Frederick Aucher. This is SpaceTime. Still to come. A new study of the Martian equatorial region shows it's dry as a bone, and scientists are working on a new way to manufacture metals on Mars. All that and more still to come on SpaceTime. A new analysis of seismic data from NASA's Mars InSight mission has revealed that the mission's equatorial landing site isn't just dry as a bone, but that dryness runs deep, with little or no subsurface ice down to at least 300 meters. The findings come as a surprise for scientists who had previously found permafrost just below the Martian surface at higher latitudes. The study's lead author, Vishaan Wright from the University of California, San Diego, says he found that the red planet's crust was weak and porous, with sediments that are not well cemented. There's simply no ice, or at least not much ice, filling the pore spaces. The findings, reported in the journal Geophysical Research Letters, doesn't preclude there being small grains of ice, or at least small balls of ice that aren't cementing other materials together. But the question is, how likely is ice to be present in that form? Another surprising find contradicts the leading idea about what happened to all the water on Mars. Scientists know Mars was once a warm, wet world with a thick atmosphere. But being a small planet, the molten Martian core began to solidify fairly early on. And with the core solidifying, the geomagnetic process, which creates a protective magnetic field around the planet, disappeared, allowing the planet's atmosphere and much of its water to be eroded away and degas into space. But many scientists suspect that a significant amount of the Martian water didn't degas, but instead soaked into the ground, becoming part of the minerals that make up a sort of underground cement. If you put water in contact with rocks, you produce a brand new set of minerals, like clay. So the water is no longer a liquid, but instead it's part of the mineral structure. Now, scientists did find some cement, but the rocks aren't full of it. Of course, water could also go into minerals that don't act as a cement. But Wright says the uncemented subsurface removes one way to preserve a record of life or biological activity if it ever existed on Mars. You see, cements by their very nature hold rocks and sediments together, protecting them from destructive erosion. The lack of cemented sediments suggests a water scarcity, at least in the 300 meters directly below InSight's landing site near the equator. The below freezing average temperature of the Martian equator means that conditions there would have been cold enough to freeze water were it there. Many planetary scientists have long suspected that the Martian subsurface would be full of ice, frozen as permafrost. but it seems those hopes have now melted away. Still, big ice sheets and frozen ground ice do remain at the Martian poles, and models suggest there still should be some frozen ground at the equatorial latitude with aquifers underneath. The InSight spacecraft landed on Elysium Planitia, flat smooth plain near the Martian equator, in 2018. Its instruments included a seismometer designed to measure vibrations caused by Mars quakes and crashing meteorites. Scientists can tie this information to a huge mass of knowledge about the surface, including images of Martian landforms and temperature data. The surface data suggested the subsurface might consist of sedimentary rock and lava flows. Still, the team had to account for uncertainties about subsurface properties such as porosity and mineral content. And seismic waves from Mars quakes provide clues as to the nature of the minerals they're travelling through. Possible cementing minerals such as clays, calcites, gypsum and kaolinite affect seismic velocities. The authors applied rock physics computer modelling to interpret the velocities derived from the InSight data. They then ran their models 10,000 times each in order to get uncertainties incorporated into their analysis. But the simulations showed a subsurface consisting mostly of uncemented material best fitted the data. Scientists want to probe the subsurface of the red planet because if life exists on Mars, that's where it's likely to be. You see, there's no liquid water on the surface, and subsurface life would be protected from radiation. Following the upcoming sample return mission, NASA's priority for the next decade is a Mars Life Explorer mission concept. The goal will be to drill at least 2 meters into the Martian crust at high latitude in order to search for signs of past or present life, where ice, rock and the atmosphere all come together. Already under consideration is the proposed International Robotic Mars Ice Mapper mission, which would help NASA identify potential scientific goals for the first human missions to the red planet. This report from NASA TV.
InSight has been fantastically successful. We've gotten more science than we had ever dreamed that we would get during the course of this mission. InSight's primary goal was to better understand how the terrestrial planets, the rocky planets, formed and evolved.
First, we landed an incredibly sensitive seismometer on the surface of Mars, and with that we were able to record over 1,300 Mars quakes.
And these range all the way from tiny little tremblers that just barely go over the noise background to a handful of quakes that were larger than magnitude 4.
And feeling those vibrations, the scientists can actually take that information and use that to reconstruct all the material that those Mars quakes traveled through and thereby see the interior of the planet.
We looked at its core, which is big and not very dense. We looked at its mantle, which is not so hot. And we looked at its crust, which is not too thick and not too dense compared to some of our pre-mission expectations.
By measuring the detailed structure of the inside of Mars, it gives us a snapshot of what the planet looked like 4.5 billion years ago. The other thing that we've been able to do is make a very detailed record of the weather at Mars. So we have a really good weather station, which has allowed meteorologists to study the weather at the InSight landing site and relate that to the climate changes on Mars.
What we didn't do, unfortunately, was make the heat flow measurement we wanted to make. Our heat flow probe was supposed to get 3 to 5 meters down, and we were unable to reach that depth.
But we were able to get some of those measurements, such as the heat transfer amongst the soil.
InSight is a solar-powered mission. We have solar panels, and they were designed to give us enough power to easily get through the first 2 years.
But there's a lot of dust in Mars' atmosphere, and that's falling down on top of our solar arrays and slowly blocking the sun.
As the panels are getting dustier, we started racking our brains with whether there's anything we can do to try to clean off those panels ourselves.
When the idea of using dirt to clean the solar arrays was first proposed, it seemed counterintuitive.
We were actually able to use the arm and the scoop to scoop up some soil from the ground and dump it over the lander, having some of that heavier sand blow onto the arrays and knock some of the dust off. So we essentially used it as an array cleaning tool.
Cleaning with dirt actually worked.
It allowed us to actually keep the instruments going during the low power season where the Mars is farthest from the sun during the winter. Unfortunately, later this summer, we think that the power is going to be dropping so quickly due to the atmosphere getting dustier, due to the alignment of Mars and the Sun.
We're going to be at a point where we can no longer have all of our instruments on, which means we'll be turning off the seismometer and other instruments on board.
The last day is going to be bittersweet. Obviously, we're preparing for it. We know it's coming. But that first moment where we don't hear from the lander when we expect to, that's going to be tough.
It's left a permanent mark on me.
We've really rewritten sort of the chapter of the encyclopedia on the interior of Mars. That was our last big hole in our understanding of the planet.
There's a lot of data that people are going to be looking at for decades to come.
We accomplished so many of our science goals, and we're going to have something to look back on and be proud.
And in that report from NASA TV, we heard from InSight's principal investigator Bruce Bannard, InSight project scientist Mark Panning, InSight Science and Instrument Operations lead Elizabeth Barrett, and InSight's deputy project manager Kathia Zamora Garcia. This is SpaceTime. Still to come, scientists working out how to manufacture metal on Mars, and later in the science report, Iran getting closer to building its first nuclear weapon. All that and more still to come on SpaceTime. Scientists are working out how to manufacture metals on Mars. The process would use concentrated solar energy as a heat source and carbon, which is produced by cooling carbon dioxide gas from the Martian atmosphere and which is a byproduct of oxygen production together with local Martian soil to create metallic iron. Oxygen extraction has already been demonstrated on Mars through the MOXIE program. MOXIE is the Mars Oxygen In Situ Resource Utilization Experiment mounted on NASA's Mars Perseverance rover. The metal extraction process being developed by Swinburne University would be coupled with a future oxygen generation plant, much larger than MOXIE. That should be able to co-produce oxygen with an iron alloy as a byproduct, and that could be used to create metals. These metals could then be used to further human missions and development on the Martian surface. A new study has warned of the increased cancer risk astronauts face due to space travel. While it was always known that deep space missions to Mars would cause a dramatic increase in cancer risk because of their heavy dose of cosmic rays and particles from the Sun, flights in low Earth orbit were considered safer because of the planet's protective magnetic field. However, new research reported in the journal Nature Communications claims astronauts' blood is still showing signs of DNA mutations in blood-forming stem cells even after 20 years. The study has involved 14 space shuttle crews. The authors say the mutations, though unusually high considering the astronauts' average age, was still below a key threshold for concern. They suggest that astronauts should be subjected to periodic blood screening in order to keep an eye on possible mutations. NASA's already looking at restricting long-distance space flights to older, more senior astronauts, whose age make them less likely to be impacted by long-term effects. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTimeWithStuartGary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.